In this channel we talk a lot about complex systems. And you know, since they are complex systems, when you make a model of them, you should need some kind of complexity, right? But today we're going to discuss about this. Actually, how much complexity do you need for a model? And it is actually always true that more complexity means better model? Spoiler alert, no. But we will discuss this in a second. So hello agents and welcome back to Social Complexity, a channel where we discuss about our society using tools from complex systems, simulations, mathematical modeling and even video games. Because yes, video games are fun. So, complexity in complex systems, how much do we need? And for answering this, let's try to model something peculiar. Let's try to model a smartphone, shall we? So I'm pretty sure you all know that there is a thing called quantum mechanics, which is pretty much classical mechanics on steroids, and that is dedicated to work really well with really tiny things like the transistors of this phone. Maybe this is a bit old, maybe get bigger transistors, I don't know. But anyway, quantum mechanics definitely would be a good job. So let's introduce our first model and see how it will look like. This model is based on quantum mechanics and it works this way. You measure the state of your phone. Let's suppose we can do it. I know it is impossible, but just pretend we can do it. And then your computer runs for probably some billions of years. But let's just pretend it does it like instantly. And then is able to tell you the state of your phone after 1 second. For example, if I press in one part of the screen, it will tell me like what the phone is going to do in 1 second. Okay, not bad. What is the competitor of this model then? So we got model number 2, which is something like really simple. And it tells you that if your screen is on and you press the WhatsApp icon, then WhatsApp will launch. Pretty simple model, huh? Okay, then what is the best model? And the answer here is we don't know. Actually, it's not like we don't know, it's mostly like the question doesn't really make sense. Because if you want to judge a model, you need also some kind of application. So let's find one. And we want to use these models to, let's say, just send a text message to someone. And the simple model is pretty much working okay because it tells you like just press this button so your screen turns visible, just then press home, then go on text and then do all the things for sending the text. I'm making it short because it's boring, but I think you got the point. The quantum mechanics model instead, it's kind of messed up from this point of view, because even just for doing this simple operation, you need to first simulate what happens when you press this button. So you have to measure the entire state of your phone, which again, we suppose is possible to do it. Then you run everything and then you have your output. And your output is going to be disgusting. I'm telling you this because actually the output is written in the form of the model. And since the model is representing the phone by representing its quantum state, so for simplicity, let's say just that it's telling you the voltage of every part of this phone. Actually, your output would be just a list of voltages of every single point of your phone. So definitely you cannot directly use this output because no human can read anything like this and make sense and say like, oh yeah, I know that all these voltages actually mean that your screen is on. Like, it's impossible to read anything like this. So then you need another model to plug on top of this model, and this second model is going to simplify your output. And this one is going to tell you like, if all these voltages are in this way, then it means that your screen is on. And if you think about it, it's pretty much a super complex, time-consuming and kind of stupid way to say like, if I press this button, my screen is going to turn on. So some way we are back to our simplified model. Now, does it mean that the simplified model is always better? And the answer is no. Because for example, if you want to know the voltage of the logical gate within this phone, then you need another model. Okay, so then what we just figured out. So the first important point is the fact that to really know which model is better, you need an application. You cannot say a priori if this model is better than the other, because really, in some cases one would be better, In some other cases, the other one would be better. The second thing is that actually complexity is not always the right answer. Or at least it doesn't mean that the more complex, the more inclusive a model is, the better. Because take for example this pen. If I throw this pen, I can predict its trajectory using mechanics. But then think about how many forces I should include, because there is gravity from Earth, there is the friction from air, but then we are really in an entangled system, so should we include also gravity from the moon? Maybe also gravity from Pluto? And maybe also gravity from all the stars from other galaxies, which are really far away, but still, they might have some kind of effect on the trajectory of this pen. And the answer is no, like in most cases, like don't even think about doing something like this because it's impossible. And also it's useless because probably if you include all these terms, maybe you will correct your trajectory of 1 nanometer. So again, if you really need this precision, then yes, go ahead. But if you don't need it, then don't even think about this. So to put it clearly, no, in general, we don't want to add more complexity to our system because then our system becomes a mess. And we cannot use it, we cannot get the result, we cannot make sense of it. So every time we build a model, we really need to be clear on what we want to model, what our answer should look like. And so we want to include as much complexity as we need, but we don't want to exceed it. We don't want too much complexity. I hope it was clear. If you have any question, please just ask me in the comments below. Also, let me know what you really would like to see next. And don't forget to subscribe, put like, hit the bell button so you can receive notification every time I post a new video. It's once per week, every Monday. I've been Dino, and don't forget to embrace the complexity of your life.